And then I will make a constraint. First one is send out constraint. I have to send out all from x1, from x2, from x3. No, this is x is not. So how much is sent out from the group 1 is this one is from 1, right? Plus this one is also from 1. Plus this is also from 1. And this number should be the same as how much? This much is 275,000. Okay. Okay. From 2, this much plus this much plus this much will be the total number of bushels sent from group 2 also should be equal to should be equal to 400,000. And from the third group, this plus this plus this should be equal to the 300,000. 300, 1, 2, 3. So you can get this number from here, right? 400 here, 275. So this makes sure all the switches we have has been sent out. And then capacity constraint. So what is the plant 1 receive? How much is going to the plant 1? This is this one, right? It's this one plus this one is from 2 to 1, from 2 to 1, plus from 3 to 1 have to be less than or equal to its capacity. So capacity is 200,000. And then how much this one plant 2 will receive is this one plus this one plus this one. Also, this should be less than or equal to its capacity is 600,000. And then plant 3 receive amount is what? This is also 1 to 3 plus this is 2 to 3 plus this much is the 3 to 3. Should be less than or equal to its capacity is 2 to 5,000. Okay, also non-negative because you cannot send a negative number of bushel. So you set everything. So I will use this one as my objective function. And this is my constraint. Okay, so let's bring up the Excel solver here. Solver appeared. My objective function is this one. And I'm not maximizing, I'm minimizing by changing of these 9 numbers. These 9 numbers are my objective function. And then constraint I have to add. You can do one by one, but no, this is the possible. You can just do the 3 by 3. I don't do the 6 of them because this top 3 has an equality and the later 3 has a inequality. So you cannot do all 6 constraints at once. But you can do the 3 by 3. So these 3 numbers should be less than equal to these 3 numbers. Okay, or you can do one by one. It doesn't matter. So again, this problem This is my objective function. Objective function here. And this is my the decision variables. And this is my constraint, and this is my constraint. Okay. And then I have to choose linear simplex LP, and then you click the solve, and computer will calculate. Something wrong. I choose. Oh, that's why. Okay. If you look at this constraint, this is the should be equal, but I type in the just okay. I will change. This one should be equal. I thought I changed it, but anyway, so it's equal. So now this is equal. The last three is less than or equal. So if you don't send out anything, your transportation cost is 0. That's best, obviously. But actually, we want to send out all the features we have. So I will solve it again. Now you got your answer. So let's keep the answer, and you can see this is how much you can get, how much you have to pay for the transportation cost. And then so you can see it's a 0, which means you are not sending any features from 1 to 2. Here is a 2 to 1, you are not sending out anything, and so on. This is your decision variable. So you will know how much, how many number of bushels should be sent from 1 to 1 and 1 to 3 and 2 to 2 and 2 to 3 and so on. And you can answer what is the object optimal solution.